not 4.1, but yesterday on April 1st, we started talking about solving logs, and we looked at just log expression, a single log expression. And there we did an example with different bases and common bases. So now we're going to look at the reverse. We're looking in reverse order. To solve those logs, we isolated the logs, we rewrote them into exponential form, and then we solved for x. Now we have equations that are starting in exponential form. Okay, so we want to be able to solve exponential equations using logs. Before spring break, back in Unit 8, Part A, we solved exponentials where we could get the bases matching on each side. Do y'all remember that? If you could get a matching base on both sides, then the exponents must be equal. It was the one-to-one property. But sometimes you can't get the bases to match. I cannot turn 17 into 3 to some power. Okay, I cannot use one-to-one property here. So the alternate way to solve exponentials when your variable is in the exponent is to use logs. Okay, so the steps should look similar or familiar. They are very similar to yesterday's. Step 1 is to isolate, and this term, and this time it's in the exponential term. Okay, then we convert it to a log, okay, which is going to bring that exponent out, that variable out of the exponent, and then we're going to solve for the variable. Okay, so again, I will write the conversion that we've been using for over a week now. Hopefully you're really familiar with this. We're going to go from this exponential form to log form, where the base of the exponential becomes the base of the log. What the exponential was equal to is the argument of the log, and the exponent is what the log is set equal to. Okay, so that's the conversion we're doing in step 2. So step 1 is done. The exponential expression is already isolated. There's nothing outside of this base to a power that needs to move. So I'm ready to rewrite this. Okay, again, the base becomes the base of the log. Okay, so here that's the 3. So I'm going to have log base 3. Okay, what the exponential was equal to, and I think I'm using the wrong color than I used yesterday. Let's switch. What the exponential was set equal to is the argument of the log, and then the exponent is what that log equals. So now I've actually already solved for the indicated variable. B is already alone now, isn't it? So now all I have to do is plug this into the calculator. Now, when you test, it may not ask for a decimal answer. Okay, we're going to be testing you not only on can you type this in Desmos, but did you do the steps correctly? So we would check, you may be asked to leave it in this form, just rewriting it. Okay, if you do plug this into Desmos, I'll tell you it comes out to approximately 2.579. And when you're practicing this in Delta Math, that's what they're going to be looking for. Okay, I'll show you Desmos. So remember, to get the base on your log, one more time, you'll go to Functions. You'll scroll down to where it says the calculus, and you need the log with a base so that you can type in, it's a base 3. I already forgot what it was. Log base 3 of what? 17? Thank you. And you can see this is where I got this. Now, I rounded to the thousandths because I believe that's what the Delta Math practice is going to ask you to round to. So I look here at the 8 is in the thousandths place, but the 9 would round it up. Okay. So I'm rounding to the thousandths place. Now, you can also input this or rewrite it using the change of base formula. You are going to have questions on your test about change of base formula. So you can't just forget about it since we already talked about it, okay? So your other option, okay, that you are going to have to be able to do on the test is using change of base formula, okay? So we used this. Okay, now the other thing we're going to use here is change of base. Okay, it says if you have a log base, that's okay, so not a common log, you can rewrite it as a common log of A over a common log of B. Does that look familiar? So instead of having to go and type a base of a log, you could plug this in as log. Okay, the base was 3, and then it's the argument is 17. So log of 17 over log of 3. Okay, so that would technically be a correct answer as well. Okay, again, I'm just going to make a note here. You do need to be able to do this for the test. Okay, but in your practice, this is what Delta Math is having you do. Just get the decimal answer. You actually need both those pages. Okay, so you do need to know both. Okay, if you need to label this as change of base, label that as a reminder. This is change of base. You don't have to have the formulas memorized, like the properties and things and the change of base. I will give you like a formula chart that is going to help you, that you get to use on the test and the review. I'm actually going to give that to you tomorrow when we do our practice, so you can get in the habit of referring to it. So far, so good? Okay. Now, number 2 says we've got a base 6 to the power of 5t equals 8. Again, the exponential term is already isolated. There's nothing outside of this base to a power that I need to move. There's no coefficient. There's nothing being added or subtracted. It's isolated. So I'm ready to rewrite this in log form. Okay, so again, my base is 6. So this is going to be log base 6. My argument is going to be that 8. And it is going to equal the exponent, which is 5t. Now this one is not already solved. Up here, when we did this, we had our variable alone. Now here, there's a coefficient on our variable. How do we move it? So I'm going to divide that 5 over to the other side. Okay, and I would simply enter this into Desmos. Okay, and I would get that t is approximately 0.232. I'm going to the thousandths place again. Okay, you do have to be able to show this step here, though. You can't just get the decimal answer, because on a multiple choice test, for instance, if there's multiple choice questions, you need both. You could take your answer choices and plug them in and see which one works, right? Everybody knows that strategy on a multiple choice test. If they're looking for a solution, plug the solution back into the equation and see which one makes it true. Okay. Yes, if your answer choices are all final solutions, you can do that with multiple choice. However, there are some test questions, and I've reiterated this to y'all. We're not just looking that you can plug things in Desmos, okay? We want to know that you know the process. So some of the questions won't have these as the answer choices. It'll have this last step before you plugged it into Desmos as the answer choice. Do you know how this was supposed to be rearranged and isolating the variable? Okay, so you can do those steps. So yes, technically you could type this into Desmos, get it as a decimal, and then plug it back in for all of your answer choices, but that would take a bit longer. Okay, it's much faster if you actually know the process to solve it. Good? All right. What do you notice here in number 3? What's different? It's not isolated. Okay, the exponential expression is not by itself. Our base is e, and it's raised to a power, but then we have this plus 5. So we have to isolate first. So I'm going to subtract the 5 to the other side, okay, which is going to leave me with e to the x minus 7 equals 21. Now I've isolated the variable. What else is different about this one? There is something added or subtracted in the exponent, but that's okay. We're still going to convert this the same. What about the base is e? What does that tell you? Now, if the base was 10, it's a common log, and you would just write log, and you don't have to write the base at all. When the base is e, does anybody remember what that special log was called when it was a base e? A natural log. Okay, so a base e is a natural log. I'm going to write this step showing log base e. Some of you are going to not have to show this step. You're going to jump straight to ln. Okay, and we're taking log of 21, and it's going to equal the exponent, which has that minus 7. Okay, so some of you, instead of writing that line, are going to be like, oh, log base e, I know what that is. That's ln. Okay, natural log. So we've got natural log of 21 equals x minus 7, and then I would move the 7 by addition. Now, are you going to add 7 and 21? Yeah, these cannot be combined because 21 is that's the argument of this log. Okay, this is not just a regular 21, it's natural log of 21. So I cannot combine these. Okay, if you want to make sure you know you can't combine these, don't put your added or subtracted value underneath it. Put it out to the side over here like this. So you don't even line the numbers up because you cannot combine them. So this can be written 2 ways. You can write it as the natural log of 21 and then plus 7. In this case, if you're going to put the plus 7 at the end, I highly recommend you put parentheses around the argument so you can see clearly that plus 7 is outside of the log. It is outside those parentheses. Okay? Or you could put the 7 at the beginning and you could say 7 plus the natural log of 21. Then it's very clear that the 7 is not part of the log, right? You put it in front. Okay, so whichever format there that you like. Okay, this is, I need my equals x. This is most likely the format that you would see on the test for answers, review and test answers. So I'll make a note of that. But in your Desmos practice, or Delta Math practice, they want you to go ahead and give a decimal. So this comes out to approximately 9.944. Okay, so Delta Math is having you go ahead and calculate it out in Desmos. Okay, on the review and test, you need to be able to give this format before you plug it into the calculator. You've got to be able to do the process and get it to here, okay, before you plug it in the calculator. Y'all feel okay about this? It's really just the reverse of what we did yesterday. Yesterday, we started with logs and changed them to exponentials to solve. Now this is starting with exponentials and changing them to logs to solve. No questions right now? Awesome. So let's go ahead and look at that second page I gave you, the 4-3. We're doing this today instead of tomorrow, so we can do a practice activity tomorrow combining all of our solving. So now we're going to focus on equations involving that natural log and that base e. Okay, when I just asked you on that last example, a lot of y'all, most of y'all couldn't tell me that that was a natural log when you have a base e. So if you need that reminder, it's right here. Kind of highlight it, box it in, bubble it in, whatever to accentuate. Remind yourself, natural log is just a base e log. Okay, e is the natural base. Okay, the rules and steps are the same for solving natural logs as they are for regular logs and exponentials. Okay, so we're just going to practice what we were doing yesterday. We're starting in log form. We want to solve, so we're going to have to isolate the log, change it to an exponential, and then solve. So if you want to put that conversion up here, if you have the natural log of a equals x, that's going to convert then the base is e to the power of x equals a. Okay, so that's our conversion this time with a natural base. Okay, still that understood base e becomes the base of the exponential. Color code that. Okay, so because it's a natural log, I know it's a base e. And then the argument, okay, becomes what the exponential is equal to, and the exponent comes from what the log was equal to. Okay, so same conversion process. It's just a base e. So it's a natural log, so I know it's base e. Then I am taking, or the exponent is going to be the 2, and the argument is what we're going to equal, which is 8x. So that would be that conversion. Is everybody good with that? How do I get rid of the 8 now to solve for x? Is the 8 being added to the x? What operation is happening when there's no sign in between? So what's the opposite of multiply? So we have to divide the 8 over. Okay, now again, this just becomes a Desmos question. Okay, they want us to solve in Desmos. We would go and just type in e squared divided by 8. Okay, and you can do that by typing in an E on your keyboard or going to the ABC button here and getting E right here. So E squared, make sure you get out of the exponent and hit divided by 8. So again, we're going to continue rounding to the thousandths. Now you may be asked to leave it in this form, e squared over 8. If they ask for an exact value, it's e squared over 8. Okay? If they ask for a rounded value, you can give the decimal to whatever place value is asked for. Okay? But e squared over 8 is technically also correct. Okay? So this is exact. This is rounded. Pay attention to your instructions and what format they want your answer in. All right, number 2, my base is E. Okay, all of these that are natural logs are going to be a base E. This time I am raising it to the 3rd power, so cubed, and it's going to equal my argument, which is 4k minus 1. So now I've got a couple steps that I need to take to isolate the variable k. So the first one is going to be what? Do I get rid of the 4 or the 1 first? Yeah, you have to get rid of the constant first. So to do that, I'm going to add 1 to both sides. And again, I can't combine these. I'm just going to write it as e cubed plus 1. Now I get rid of the 4 by dividing. So if you are asked for the exact answer, that's it. That's your exact value. Okay. If you're asked for the approximate or the rounded answer, when you plug that in to Desmos, we would get approximately 5.271. Okay, so just pay attention to the format the question is asking for. Everybody still good? All right, now this time in number 3, my log expression is not isolated. What do I need to move first? I always have to isolate the log or exponential term first. The 2 needs to be moved to the other side. It's being multiplied, so I'm going to divide. So I have the natural log of A equals 7. So this will convert. My base is an E because it's a natural log. And then it is going to be to the power of 7. And then it will equal A. Now my variable is isolated. I can just leave it like this. This is the exact solution, is e to the 7th power. If they ask you to round it though, you can plug that into Desmos and calculate it, and this is what you get. Okay, 4 is different now. Instead of starting with a log, we're starting with an exponential. And that exponential is not isolated. What needs to move first? I need to get the e to the power by itself. So what do? That 5 in front, how is the 5 connected to the e? What operation's happening between the 5 and the e? That's multiplication. If they're just butted up against each other like that, a number and a variable, okay, those are being multiplied. Okay, so to get rid of that 5, I'm going to have to divide because we have to do opposite operation to move terms to the other side. So I end up with my base e to the power of 4n equals, and then 95 divided by 5, what is that, 19? So now I'm ready to rewrite this as a log. So it's going to be a natural log because it's a base e. I know because of that base being e, it's natural log. If you need to show the step in between of writing log base e before you write ln, that's okay. You can do that. Okay, and then this is the argument. So natural log of 19. And then it's going to equal the exponent, which is 4n. So now I need to isolate that variable n. So I'm going to have to divide out the 4. So my exact answer is natural log of 19 divided by 4. But if I needed a rounded answer, if it said to round to the nearest whatever, okay, then you could write it as 0.736. Now there is an alternate process that I can show you here if you want to use it. When you have a base E exponential that you're trying to solve for, instead of converting it to log form, another way to go about it is to take the natural log of both sides. Because if you take the natural log of E, what's the natural log of E? Don't remember what we talked about? When the log base matches the argument of the log, what does it equal? For this, log base E of B equals what? 1. So the natural log of E equals 1, because the base of a natural log is E, right? So they match. So that equals 1. So if your base is E, technically, I'm just going to draw a line here and show you, because of this rule, remember we also said, okay, what if it's raised to a power? Let's call the power X. And then you could use power property and that X would come in front and that would just end up equaling X, wouldn't it? We talked about this rule. I don't know how many days ago that was. But because of those rules, what I technically could do, I have E to the 4n equals 19. Once I divide out the 5, this is where I'm at, right? What I could do is I could come over here and I could take the natural log of both sides, because what you do to one side, you do to the other. So if I take the natural log of both sides, this left side is going to simplify because of this rule here to just 4n, isn't it? So then I would have 4n equals the natural log of 19, and then I would divide the 4 over. And I end up with the same thing, don't I? Natural log of 19 over 4. So it's just an alternate way to get there. You can do it as converting from exponential to log, if that makes the most sense to you. But if you understand that what you do to one side, you do to the other, you can just log both sides, or natural log in this case. Okay, because I know the natural log of E is 1, and the power property would mean we would just be left with 4n. So that would get rid of the E and bring the n out of the exponent. So that is an alternate method for solving. I'll go ahead and put an or on top of that line. Okay, you could solve it either of those ways. Okay, if you're familiar with these rules, maybe you think this way's quicker. If not, just stick with the converting from exponential to log. Questions so far? All right, last couple. So on the back here, we've got some more complex expressions. I have to isolate the exponential expression. Okay, so the exponential expression is this part right here, the e to the negative 4x. That's what I have to get alone. So I've got a 2 in front being multiplied and an 8 being added. Which one do I move first? The 8. You move the constant first. So I'm going to subtract 8 from both sides. Then I'm going to divide by the 2. And 27 divided by 2 is 13.5. So 13.5. So now I have the 2 options. I could simply take the natural log of both sides and get it that way. Or if you prefer the converting, you can convert to log form. Okay, does anybody have a preference of those 2 methods I just showed you? Right here, taking the natural log of both sides so that the exponent is all you're left with over here, or converting. Does anybody want to see a particular way? Okay, well, I'll just show you the converting because I think that's what you're most familiar with. So what is the base of the log going to be? What's the base here? E. So what type of log is it going to be? Natural log. And I don't write base E. ln it implies that it's a base E. Okay, then I am taking the log of this argument, so 13.5, and it's equal to the exponent negative 4x. Now, how do I get rid of that negative 4 that's being multiplied by the x? So I divide by negative 4. So my exact answer is the natural log of 13.5 divided by negative 4. Or you could put the negative in front of all of it. That's fine too. Okay. Or you could, if they tell you to round to the nearest whatever, you could plug that into Desmos. It would be negative 0.651. Any questions? Okay. So then let's take a look at this last one. We've got to isolate first. Okay, so we are isolating the exponential term first. Okay, so in this one, that's e to the c minus 9. So I'm going to move the constant, which is 3, by opposite operation. I'm left with 2 times e to the c minus 9 equals 84. Then I'm going to divide out that coefficient of 2. Now I've isolated my exponential term. And I'm ready to rewrite this as a log. It is a base E, so it is a natural log. I am taking the log of 42, the natural log of 42, and it's going to be equal to c minus 9. So then we add the 9 over. Now again, align that over here so you know you're not combining it with the 42. So this is 9 plus the natural log of 42 equals c. You could write the 9 on the other side, but I would definitely use parentheses if you do it this way so you know the 9 is outside. Okay, and that comes out to approximately 12.738 if you round. Okay. All right. So that was good timing. We finished those notes. When you come back tomorrow, we will be doing some practice activities to make sure we've got ample time to practice. All right, y'all head out that door, go all the way back in that parking lot, past the black gate. Keep going back.